All right, so let's try number 19 and 14.1, which says I would like to try to draw a picture for x is 2 cosine t and y is 3 sine t.
Let's do the same thing.
Yeah. So basically plot this thing. And then they also want me to try to eliminate that variable t, which is going to be top here. Okay. So, thoughts?
Graph both.
Graph both things?
Yeah.
Okay. So if I'm going to graph things, what's x of t look like?
It'd be a cosine wave starting at 2.
Okay, so cosine wave starts at 2, goes to -2.
Yeah.
Okay, cool. Okay, and then y, right? Really of t. So this is x of t, and y of t looks like a dead marker.
Oh!
Thank you. Thank you. Okay, so that looks like, ooh, nice. Marker. So that looks like a sine wave with a height of 3. Cool. All right. So picture. So x and y.
Starts at 2, 0.
Okay. So when t is 0, we're out here at 2, 0. Right? That's, oops, t is 0. Okay, then what happens? Okay, so my next interesting value is kind of this hit and that spike, right?
Yeah.
Those are both happening at pi over 2. Okay, so where's that at?
0, 3.
So yeah, in the x it's 0 and at the y it's 3. So I need to go up 3 units. 0, 3. That happens when
T is pi over 2.
t is pi over 2. Okay, now how did I get there?
Curve the line. Should be a depression.
It should be kind of like that.
Wait, hold on. One's a depression, one's a increase.
Okay, so let me see. So the x's are changing fast initially, right? And then slow later.
Yeah.
You guys see that? Sorry. X's are changing slow initially and then fast later. And the y's are changing fast initially and then slow later. Right? So the y's should go down, y's should be fast at the beginning, slow at the end. X's should be slow at the beginning, fast at the end.
Yeah, man.
That seems like one of these.
Yeah, boy.
You guys see that? I'm just ignoring that. So, how do I know it's not the other way?
Because that would make no freaking sense.
Because that would make no freaking sense. Cool, I'm down with that.
Are you reading this from x going from left to right, and then y going from right to left? You said x is going slow and then
Yeah,
fast.
so, right, I'm talking about the rate at which x is changing.
Yeah.
So like at the beginning here, this thing's basically flat, right?
Right.
So x isn't really changing very fast at the beginning. And then down in here, x is changing pretty fast, right? It's going down fast. Over here on the y's, right? The y is changing pretty quick at the beginning, and then really slow at the end. Yeah, they're not proportional, because proportional is lines, but yeah. Inversely related. It's good. You guys see that? So, like here at the beginning, right? If I'm thinking about how fast stuff is changing, the y's going up really, really fast, right? But the x isn't changing very quick.
Yeah.
When I get to here, they're both about the same. And then when I get to here, right?
Y
Like
is slow.
up in here, y is really slow, but x is really scooting along.
Yeah.
You guys cool with that? Yeah, so at pi over 4, right, they're both going at the same rate, give or take. it's not actually quite true, right? Because that pi over 4, this thing's, because this one goes from -3 to 3, right? It's always a little bit faster than this one that goes from -2 to 2. You guys all sort of see that?
Yeah.
Okay, so the y rate's always a little bit quicker. All right, so what's my next piece look like?
Pi, time pi.
Yeah, so time pi,
Uh,
the x is
-2.
-2, and the y is
0.
0. So that's out here,
Yeah.
right? And that's happening, t is pi.
Mhm.
And how did I get there?
Well,
It's
this is,
Yep, it's probably a mirror image.
Yeah.
X starts going fast and then slow. and then
Okay, so I got something like this. Oh, and I never did find out the answer to your question about an oval. Still don't know what the mathematical definition of an oval is.
God dang it, you know what?
Okay, so what's the next one?
3 pi over 2?
3 pi over 2. So that's going to be down here.
0, yeah. X is 0.
We just found
Yeah. So this one is definitely an ellipse. But I still don't know what an oval is, so it might be the same thing. Who knows? Okay, so how do I know it's an ellipse? Well, I'd like to see that ellipse equation in here, right? Yeah, the y stretch is a little bit more than the x, right? It'd be a circle if they were 2 and 2. Okay, so how do I see the equation here? You guys want a trick for eliminating t's?
Yeah.
Okay. So this is a trick worth knowing. Okay. What's up?
An oval or ovoid is any curve that looks like an egg or ellipse. It is not a precise term, and there are many curves that can be called oval.
Perfect.
It's an oval.
No, an oval's a bunch of bullshit. It's like an ellipse, maybe, or other stuff too.
We need to find it something.
Okay, so
It's kind
Good.
of like an oval.
that is an oval. It is also precisely an ellipse. So my reason for this trick, and my motivation for this trick, is I know one thing about adding sines and cosines together. Yeah, there's the Pythagorean identity, right? Which says sine squared of theta plus cosine squared of theta is 1. So that's what I'm thinking here. Okay, but I don't have sine squared and cosine squared, right? You guys see that? Even if I had x squared, I still wouldn't have cosine squared. You guys see that? Okay, so what I'm going to do is I'm going to take my original equation. So I got x of t is 2 cosine t, right? Divide by 2. So you'll get x of t over 2 is
Cosine t.
cosine t. Okay? Do a similar thing for sine, and then square both of them. So if you square this thing, what do you get?
Cosine squared t.
Okay. You get cosine squared t is
X quantity squared.
x of t. Really, maybe I'll just forget the of t for a second. It's x over 2 quantity squared, right? Okay, and if I do the same thing for y of t is 3 sine t, what you gonna get? Same thing. You're gonna get sine squared of t is
Y over 3 is squared, or quantity squared.
y over 3 quantity squared. You guys see that? And what do I know about sine squared plus cosine squared? It's 1, right? So I got this blue thing out of those two. So I know that x over 2 squared plus y over 3 squared is 1 from the Pythagorean identity. You guys see that? Okay, so there's my equation for this thing. And that's the equation for an ellipse. Cool? Questions, Steele?
Looks like you just get x over 2 by looking at the graph.
Yeah, and of course you could also think, right, this looks like a circle, right? Except the x's got stretched by 2 and the y's got stretched by 3. Hey, that's shifting rule. Cool? Crazy, right? Okay, so why did the t's disappear? So what I know, right, is I know that sine squared of t, really, right, plus cosine squared of t is 1. So if I think about x as a function of t, really I maybe should have this, right? I should have x of t over 2 quantity squared plus y of t over 3 quantity squared equals 1. Okay. So dropping the t's loses me information. And it definitely does. The information it loses is which direction I'm going around this circle, or around this ellipse, and how fast. Does that make sense? So I really am losing information there. So this parameterization contains a little bit more than just this ellipse. This ellipse is just a graph of that
You
thing,
just get the
not
picture.
how fast and when. Does that kind of make sense?
He just kind of took his thought. He just took long.
Yeah, I'm just dropping that time information
Okay.
basically by using the Pythagorean identity. Right? Was your question about this?
Yeah, does x have to be divided by 2 and does y have to be divided by 3?
Yeah, so you need to know, so the 2 and the 3 there came from me wanting to use the Pythagorean identity and needing a sine squared and a cosine squared, right? I wasn't going to get that without dividing by the 2 and the 3,
Right.
respectively. You guys see that?